The circle C with centre at the point A has equation x squared plus y squared minus 10x plus 9 equals 0. We need to find the coordinates of A, the centre, and the radius of the circle C. So first thing I'm going to do is to write the x terms together. So I'm going to group up the x squared and the minus 10x. We'll keep the y squared separate for now. And then I'm going to complete the square on the x terms. So I'll have halving the 10, we get minus 5. And then I need to take away the 5 squared, which is 25. The y squared, now that's just by itself at the moment, so I'll just leave that. And there's no need to complete the square here because the y squared is all by itself. Then the minus 25 plus 9 is just minus 16. And I'm going to add that 16 to both sides. So this gives us the equation of the circle, where I can see that the centre of the circle, the x coordinate is going to be 5 because of the minus 5 there. And the y coordinate of the centre of the circle, well, it's just going to be 0 because we've got a y squared there. It's almost like imagining having a y minus 0 there. The radius of the circle, well, r squared is 16. So r is going to be the square root of 16, which is 4. Part C of the question says to find the coordinates of the points at which C crosses the x-axis. Now I know it's going to cross the x-axis when y equals 0. So I can either substitute 0 in here, into this equation, instead of the y, or I could substitute it into here, in the original equation, which I think is probably what I'm going to do. I just prefer the look of the first equation. So if I substitute 0 into that first equation, I just get x squared minus 10x plus 9 equals 0, which I can factorise. And I find that x will equal 9 or x will equal 1. So the coordinates of the points where the circle crosses the x-axis are 9, 0 and 1, 0. We're then told that the line L has gradient 7 over 2 and is a tangent to the circle. We're told that the line touches the circle at point T. We now need to find an equation of the line that passes through A and T. Now remember that A is the centre of the circle and T is the point where the tangent touches the circle. So we're working out the equation of the radius here, if you like, because the line that passes through the centre of the circle and T, the line that passes through the centre of the circle, A, and point T is going to be the radius. Or it's going to include the radius anyway, which is going to be perpendicular to the tangent. Which means that its gradient is going to be the negative reciprocal of 7 over 2. So I'm going to write down y equals m x plus c. So let me just repeat that logic one more time. We're trying to work out the equation of the line that passes through the centre of the circle and the point T, which is where the tangent touches the circle. Therefore, the gradient is going to be the negative reciprocal of the gradient of the tangent, because we know they're going to be perpendicular. Now, because I know it goes through the point A, I can substitute point A, which remember is the 5, 0, in here. So the y coordinate is 0 when the x coordinate is 5. So therefore, we get minus 10 over 7, and that's going to be our C. C is minus 10 over 7. So the equation of our straight line then is y equals mx plus c. And it doesn't say how we need to leave our answer in this case, so I could just leave my answer like that if I wished. We could obviously times through by 7 and move everything to one side if we wanted to write it in a simpler form, but it's perfectly fine to leave it like that here.